Pearls are not the tears of mermaids or sharks or princesses denied their lovers. They don't form a dragon's brain or from lightning strikes on waves, or Venus shaken sea foam from her hair. They are not the loved children of oysters and dewdrops or fathered by moonbeams. For millennia, though, people speculated they might be, the myth that a pearl grows when a grain of sand gets stuck in the oyster's soft body persisted to this day. But oysters are filter feeders, siphoning plankton-rich waters through their gills and adeptly ejecting sand. If grains of sand of the tears of every boiled princess made pearls, they'd be as plentiful as pebbles at the tide line. Far from being abundant, though, natural pearls are found in a scant fraction of oysters and other pearl-bearing mollusks. The chances of finding a large, unblemished, lustrous globe are vanishingly slim. Like our bones and teeth, pearl form through biomineralization, the process by which living organisms create mineral matter. Perhaps this helps explain our long attraction to them. They are both miraculous and familiar. A diamond might have formed billions of years ago, hundreds of kilometers beneath our feet, in unknowable heat and pressure. A pearl, though, is made by an animal that thrives in waters, sometimes so shallow we can wade in them. A pearl can form in the time it takes a child to grow half a meter. The fire flash of a diamond recalls Earth's unvisited upper mantle. The gleam of a pearl recalls an infant milk teeth. The pearl is the oyster autobiography, claimed the Italian film director Federico Fellini, defending his argument that all art is autobiographical. We might think that an oyster's famously pygmatic and sedimentary life lacks plot. You are enough to try the patience of an oyster, snaps a young crab to its mother in Alice's Adventures in Wonderland. But thinking of a pearl as the story of an animal responding to the ever-shifting environment might be the most helpful way to understand its creation. The oldest extant pearl found in 2017 in the United Arab Emirates has been radiocarbon dated to between 5800 and 5600 BCE. But pearls' beginnings reach much further back to the Paleozoic era, about 530 million years ago, with the emergence of mollusks, popular on the menu today as though much of a human. This diverse group of soft-bodied invertebrates includes octopi, squid, snails, scallops, oysters, and mussels. By the Cretaceous period, 65 to 145 million years ago, pearls abound in the fossil record. The age of dinosaurs was also an age of pearls. Fossilized pearls from saltwater and freshwater mollusks have been discovered across the globe. They range from dull blisters to shell fragments, to bumps slicked with iridescence, and even to the rare glossy orb. Humans likely first encountered pearls as the tooth-cracking byproduct of our earliest forages for food, and archaeologists still unearthing them from prehistoric kitchen middens. There are more than 100,000 living species of mollusk and at least 60,000 fossil species, but very few bear pearls. Most mollusks capable of producing jewelry-grade pearls are bivalves, and they owe their feat to their rudimentary but efficient anatomy. In essence, they are water filters, and the unique qualities of water is mirror build the character of the pearl, true of their name. Bivalves have two hinged shells. Their adductor muscle control the opening and closing of the shell valves. They strain water through their gills for food and respiration, and their soft bodies comprise organs for circulation, digestion, and reproduction. Outside, the animal might be as prosaic as a pebble, but as the French poet Francis Ponge marveled, inside the whole world awaits. The anatomy of this unassuming animal, arranged to maximize water circulation, leaves generous open space for the accidental formation of a pearl. A platter of glistering oyster on the half shell is likely to disappoint a pearl hunter because edible oysters belong to the family Ostidae, while pearl oysters belong to a different family, Pteridae. The genera Pictada and Ptera bear the most valuable gems. Of these, a few superstar species birth the gems that have made their way to the ears of pirates and the necks of queens and Mughal princes. The length of a pincal finger, the delicacy rate Pictada radiata, or the ordinary pearl oyster, has pumped prodigal quantities of extraordinary pearls onto world markets. Until the 20th century, most saltwater pearls used for jewels and stores of wealth were from this species, which inhabits the Persian Gulf, home of the most fecund oyster beds, the Red Sea and the Indian Ocean. The diminutive Pictada radiata has played an outsized role in world history. When European colonists in the 16th century discovered vast banks of the pearls off the coast of Panama, Colombia and Venezuela, they ignited a pearl rush fueled by the transatlantic slave trade. Pearls from Pictada radiata are typically under a centimeter in diameter. More Blin South Sea pearls form in the dinner plate-sized Pictada maxima, the silver or gold-lipped oyster, which inhabits the eastern Indian Ocean and the tropical western Pacific. Black pearls come from Pictada margaritifera, the side plate-sized black-lipped oyster, which lives in some of the same waters, the lapaz oyster Pictada mazatianica, found in the eastern Pacific between Mexico and Peru, produces silver-shinned pearls. Pictada fucata, the small Akoya oyster, has been the workhorse of the modern cultured pearl industry. These were the oysters that the Japanese entrepreneur Kokichi Mikamoto used for the world's first industrial-scale pearl farming in the early 20th century. The maxim that irritated oysters make pearls is only partially correct, as not all pearls come from oysters. Abalone, a marine gastropod, can make tooth-shaped pearls as green, blue, or split petrol. The queen conch, fished for its succulent meat, occasionally bears luxurious candy pink pearls. The mellow sea snail, with its startling zebra-shaped body cured in a yellow volute, can grow spherical flame orange pearls, exotic as tropical fruits. We associated pearls with the sea, but freshwater mussels can grow pearls in shades of salmon pink, lavender, pewter, and every nuance of white. For cultures, European aristocracy and the Russian Orthodox Church look to freshwater mussels to help feed their colossal appetite for pearls. The European pearl mussel Margaritifera was once endemic to cold, fast-flowing rivers from the Arctic to Portugal and from Russia to the northeastern subboard of North America. Overfishing and industrialization led to an extinction of many rivers, and it is now classified as critically endangered in Europe. While saltwater Akoya pearls are still cultured in Japan and other countries, most cultured pearls are now farmed to Chinese freshwater mussels. The triangle pearl mussel, Huropsis cumingi, is a species as accommodating rush-hour public transport, crowding more than 30 pearls into one mussel. China is the world's pearl cultural behemoth, producing 3,500 tons or more than 3 million kilograms annually, representing over 98% of global production. Of this, 99.5% are cultured in freshwater mussels, nullifying the popular equation between oysters and pearls. The United States had its own fevered pearl rush in the mid-19th century. The gems from freshwater mussels were of such high quality that they made their way onto European markets, disguised as oriental pearls from the Persian Gulf. North America still has a dizzying variety of freshwater mussel, species. Though the ravages of the pearl rush and economic development have reduced the number of pearl-bearing species to around 20, from a 19th century high of 300. Rare natural pearls can still be found along the Mississippi River basin and have a niche following with artisan jewelers and their clients. Whether freshwater or marine, all pearl-bearing mollusks grow pearls through biomineralization, and same process that forms their shells. Their genes determine the gemological advantage over other mollusks. The creamy, briny flesh of an edible oyster is cradled by shell with the milky opacity on the bottom fixture, but the inner shell of a pearl oyster shimmers like a rainbow. With the benefit of hindsight, it seems obvious that the pearl shares this nature, but it would take until the 17th century for scientists to affirm that the pearl and the inner layer of the shell are the same nacreous material. Nacre consists of around 82% calcium carbonate, the same material as eggshells, 10% caoutchouc, a protein glue, 2% water and trace elements. The material is secreted by cells in the animal's mantle, the thin membrane attached to the inside of the shell that envelops its soft inner body. When Plato wrote of the body in which we are imprisoned like an oyster in its shell, he might have been thinking of the ruffled mantle, tightly binding flesh to shell. The classical world ascribed pearls to dewdrops seeping into the oyster, a myth that stubbornly persisted through the Middle Ages. It was well into the 19th century before German scientist Theodor von Hessing insisting on the key role of the mantle. Epithelial cells in the upper layer of the mantle secrete liquid that hardens the form the nacre that coats the shell's inner layer. When a tiny intruder such as parasite gets lodged between the shell and the mantle, it can carry a few nacre-secreting epithelial cells further into the mantle tissue. These cells multiply around the foreign body as a form of defense, creating a cyst or pearl sac. The sac begins its slow medicine, secreting layer upon layer of nacre around the intrusion, evenly forming a pearl. The pearl sac, not the parasite, makes the pearl. In fact, a pearl may develop in the absence of any foreign body, possibly triggered by abnormal growth of epithelial cells.